Hello, and this time we're looking at surface area. And the key about surface area is just to work out areas and then add them all up. So you work out the area of each face around your shape, around your solid, and then the total surface area is just adding all those things up. So if we look at the first shape, we've got some rectangles. We've got three different kinds of rectangles. The front and the back are the same, and they are 3x2 rectangles. The sort of middle darkness of green here is 2 across and 4.5 along here. So you've got to just carefully map your numbers. 2 times 4.5, and there's top and bottom, they're the same. And then the right hand side here, the lightest green, is 3 by 4.5, and again there's one on the right and there's one on the left. There's 6 faces in total, and we just need to work out all 6 faces and add it all up, or you could work out these 3 faces and then double that to give you the 6. For this middle one, we've got the area of a triangle, and then the same on the other side. So we've got 2 of this triangle, and then we've got 3 different rectangles. We've got this big rectangle we can see, which is 6 times 13, and then the base is 5 times 6. Imagine that underneath there. And then the left hand side, which we can't see, is 12 times 6. So, well, let's just look at this last one whilst we're here as well. We've got a funny shape here, but we can sort of cut a bit off and work out this area and work out this area and add that up. And there'll be 2 of those, one either side. And then because there are 6 sides to this weird shape, that means there's 6 rectangles going around the outside. And that's true for any prism that you do, is that there'll always be the cross-sectional area twice at the front and the back, and then as many rectangles stretching back as there are sides around your cross-section. So when there was a 4-sided cross-section, there's 1, 2, 3, 4 sides. When there's 3 for the triangle, it's 1, 2, 3. And when it's an irregular hexagon, then there's 1, 2, 3, 4, 5, 6. And you need to work out the area of each of these. Now there is a little shortcut you can do, which is you can work out the area of the cross-section and double it, and then you can work out the perimeter of the cross-section and times it by the length of the perimeter, the length of the prism. You can imagine if you sort of unrolled this, you know, you've got the triangle there, and, well, that's not a very good picture. You've got your triangle there, and then you've got these 3 sides, 1, 2, 3, these 3 sort of, yes, going around the outside, 3 faces that stick onto this triangle. And if you imagine unwrapping it, so this side and this side sort of hinge over, it'll just stretch out as one big rectangle, the length of the prism, that then, if it's like a piece of paper, like you're wrapping up a present, you'd sort of fold it up so it sort of comes up along here, the base going along there, and then the top bit here would fold down. And that means that if you want, you can do a slightly easier thing to remember, is that the surface area for a prism, this only works for a prism, is going to be 2 times the cross-section area plus the perimeter of the cross-section times the length of the prism. Okay, so that will always work for a prism. Of course, if you've got other shapes, if you've got a pyramid or something like that, you just have to work out each of the areas of the faces. Now, it does require you to also know your basic area formulae. So for a rectangle, it's base times height. And for that's for a rectangle. And for a triangle, it's going to be base times height and half it. Of course, you can do it for cylinders, and you can have trapezia, and whatever the shape might be, you just have to work out areas of circles and trapezia and parallelograms and whatever the shapes might be. If it's the face of the object, then you work out its area, excuse me, and you add them all up, and that's going to give you your total surface area. So let's just run through these examples nice and quick, just so that you sort of see it in action. Okay, the first one we're going to do is this one here, so we're going to call this the cross section. Of course, for a rectangular prism, you can imagine the prism sort of going this way, or this could be the cross section going that way, or this one going down. It doesn't matter because it's sort of a prism in all directions, if you see what I mean. If we treat that as the cross section, that's 3 times 2. Okay, and then we can double that because there's one at the back, so times it by 2 again. So that's the area of this bit and the area of the end. And then we can say plus, and we need the perimeter of this, which is 3 plus 2 plus 3 plus 2. And we're going to times that by the length of the prism times 4.5. And typing all that into the calculator will give you the answer. The other thing you can do is, like I said, you can do it in each side separately. So 3 times 2 for the front, plus 3 times 4.5. Sorry, 3 times 4.5, plus, and then the top is 2 times 4.5. And then, of course, we've got 6 faces, not just 3, so you'd have to double the whole thing. Make sure you've got it in the bracket so the whole thing gets doubled. And again, you can just type that all onto the calculator. Let's have a look at B. So we'll just get rid of this. And have a look at question B. We're going to need 2 of these triangles. Well, it's a bit funny because if we have 2 triangles, it's going to cancel out that half. But anyway, we'll write it out in full. So we've got base times height, so 5 times 12 over 2 because it's a triangle. But we've got one at the front, and then we've got the one at the back, so double it, which is just going to cancel those 2's. And then we've got either 3 rectangles, so you could write it out as 5 times 6 plus 12 times 6 plus 13 times 6, and then type all of that in the calculator. Or you can simplify this and say 5 plus 12 plus 13, the perimeter going around that cross-sectional area there, going around there, the perimeter times the length, just like that. And just type that in. Again, we can cancel the 2's, didn't do that before, and so just typing that into the calculator is going to give you your answer. And the last one, because we need to work out this funky area, sort of like the cutout area, there's 2 ways we could do that. We can either do it as a whole square and then take away the bit that's missing, or we can cut it off like this and work out the small area and the big area. Now it's a little ambiguous, but I'm pretty sure that that is supposed to be 30 and that's supposed to be 40. The reason being that those 2 add up to 70. And that's supposed to be 50, well that's kind of obvious, and that bit's supposed to be 10, that vertical bit, excuse me, that bit there is supposed to be the 10, because again 50 and 10 is the 60. And then the depth of the prism, the length of the prism, is 50 like that. So, if we do it by the cutting it off method, then we're going to have this bit here, which is 10 times 40, the 40 up here and the 10 there, and we're going to have this bit that's 50 times 70. So this area here, the whole area, is just adding them together. So 50 times 70, whatever that is, plus 10 times 40, whatever that is. We need 2 of those because we've got one at the front and one at the back, so times that by 2. And then we need the all 6 of these rectangles. This is why I think it's easier sometimes to do it as that perimeter times the depth. So here I know that if you've just got a corner cut out, then the perimeter of the 6-side shape we've got here is the same as the perimeter of the rectangle, if you sort of pop that back out again. You can imagine that that side, so just shove these out to there, and this side just moves along to there. It's the same as the rectangle. So I can write this easily. This is 60 and 70 and a 60 and a 70. So I don't have to do all this little adding. So 60 plus 70 plus another 60 and 70, so times that by 2, so that's the full perimeter, 60, 70, 60, 70. And then we need to times that by the length of the prism, which is 50. So, I mean, very long calculation to type into your calculator, but hopefully you can see exactly where each bit comes from. And I don't personally work out each of these. I write all of this out and then I type it all carefully into the calculator. The reason being that in the exam, the examiner can see that that's an attempt to find the correct area here, that's that area there, that is finding the perimeter and then timesing by the length. So you're showing all of the bits that you are trying to do, and the examiner's not having to sort of scout around for it. And then also, if you get a funny answer and something you're not expecting, you can then go back and say, okay, well, where are all these numbers? And you can then proofread your method very clearly because it's all laid out in a row. Now, as I said, if you've got something strange, if you've got something, not strange, but if you haven't got a prism, is what I mean, if you've got like a pyramid, then you can't do the sort of the perimeter method I just showed you. But if you've got a pyramid, then you're going to work out 1, 2, 3, and 4 triangles, and then the area of the square at the bottom, and add it all up, assuming it's a square-based pyramid. If you've got a cylinder, then you're just going to work out the area of the circle twice, and then you're going to have a big rectangle around the outside. This is a prism, so it's the same rule. You work out the perimeter, or the circumference, and times it by the length of the cylinder, or the height, and that will give you the area of the big rectangle that stretches around, just like it did here. If you have any other questions, then pop them into the comments, but otherwise, cheerio.